Testing, testing, testing. How are we doing? Is it working? I guess I could share this.
BSC Streams channel.
No. I mean, maybe. Where is that? Oh, here, streams. That thumbnail is so good. Okay, and then I can quit Discord. Here we go. It's happening. So let's see. Okay, what's the story here? What are we doing? The story is, I don't know. We'll see. Well, I mean, look, it's pretty simple. If the compiler doesn't currently compile itself, that's the problem. So if we go back to like here, me doing kernel stuff. Here we go. So this currently does not work because, well, it's broken. I've been rebuilding the. It's broken.
That doesn't work. Well, it's broken.
Well, we've been refactoring and redoing. So it currently does not work, as you can see. So it'd be good if it did work, I decided. Wait, what was arguments reg count? I mean, I think I know what that means.
The delay is so bad.
What delay?
I went to the stream, and it was like after you stop talking.
Yeah.
I get like you talking.
I don't know. You're not a streamer, so I don't think you're aware of the latency. That's pretty normal.
Pretty weird. No, I know it's normal. It's just also bad.
Oh, sure. But they have to re-encode it and send it to the big network of servers and stuff. I mean, not for this stream, because nobody's watching, so they probably don't need to do anything. Anyway, 1723. Arguments reg count. Pretty sure this is just well. All blocks I instructions think this will be a bug, actually. Well, and we kind of don't want to just relentlessly copy stuff. We would like to make it good. This is the debug info. Stack space counter. Okay, what we're gonna do. Brennan, do you know what I guess you've done like normal System 5 calling convention stuff? Is that like TB handles that?
TB handles it. System 5 is a shit show.
Really?
Yes. All my homies hate System 5.
Why is that?
It's just like it's not like it's consistent LO format. I think there's a lot of stuff you have to do differently depending on what you're doing,
Mm-hmm.
as opposed to like the Windows calling convention. I think there's stuff, stretching stuff into vector registers and
Oh.
weird things. Well, like Bill hates it because LLVM doesn't support it directly.
Really?
Yeah,
It's like their primary target.
Yeah, but you also can't, like, you have to implement the calling convention yourself, but you can't implement it directly. You have to like, implement it in LLVM IR,
Mm-hmm.
which is a shit show.
Okay. Okay, well, what's the normal? Like, so what I want to do is I want to now do the stack frames all in exact size, kind of mirroring what we're going to do for RISC-V. What should I be doing for calling convention? If we still presume I don't want to pass everything on the stack.
I mean, you don't have to do System 5, even on Linux, like, because you're not interfacing with C.
Yep, I guess so. So what's the simple thing then?
Oh, you can just invent it, right? Just define, like, alright, this register, this register.
Okay, let's do it then. I mean, do we have paper? Let me get paper. This would be a bad stream for people. But
You gotta get the above head webcam like camera. Or you could be like, you know, use Milton.
I don't have a digital pen and I don't want to draw with the mouse. Right, look. RBP, RSP. Probably don't want to change that too much, right?
You're gonna use RBP, like you weren't frame point.
Oh, true. But okay, can the debug info handle like this thing? You did this thing here. The CFG, blah 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 blah.
Yeah.
Yeah. Like presumably we need to push RBP. Can you emit frame pointer?
You can just, yeah, you can just submit it. But then it'll all be broken.
What will all be broken?
The stack unwinding stuff.
All of it?
Yes.
Hold on. Here's a compiler explorer that the stream people can see. See, this function is now not called square, it's called a rectangle. It's called area. Okay, so what should I be compiling with as the example? Clang 20, 03. Will this emit frame pointer? Yes, it will. Okay, but wait, this is also a leaf. We need a call to not printf. What's a libc function?
I'm trying to think of something that doesn't have like bar args. I don't know. Libc.
I only use printf.
Yeah, same.
Oh, hold on. There. Compilation failed. Wait.
What did you do? Undeclared. No, you need an import.
How do you what? Okay. How do you import?
I don't know.
I guess I'm such a like hideous user of C that
You don't know how to import malloc. Those babies.
yeah, but I normally would just like use malloc and then I'm relying on like GCC is like hallucinating the definition for malloc and then linking it later anyway. But is it standard IO?
Maybe. Looks like I don't know. Maybe there's like a standard.
Oh, stdlib.
Oh yeah, just the whole thing.
Stdlib. Undefined reference to main. Oh, but that's like whatever. Okay. Oh, bro. It has to be an int. I don't have to return though.
Good old Zor, EAX.
Yeah, but I did look. Like this should be an error, really. This must be special case for main, right?
What do you mean? No, like C. Oh, you don't know. C has like Lisp style return, where like it just returns the last thing.
No, definitely I've gotten errors from C where it's like this. You've forgot a return statement. Look, if we do that here, it's gonna complain. Yeah, okay, wait. It gives us a warning. It gives us a warning, but it does not give us a warning for main. Look, as well. Look at the difference between these two. For main, it adds the Zor EAX thingy. For here, it does not. It just goes like, well, return undefined behavior. Alright, anyway, wacky. Alright, so it's pushing RBX. Wait, why is it pushing RBX? What? I think it's omitting the frame pointer. If I do no omit frame.
Oh, interesting. If I get rid of the return statement and I have an expression at the end, it like just puts a trap instead of a return. It like doesn't do the calculation at the traps. And so if you return, boom, it does the calculation and return. If I don't do it,
These are such randomly generated compilers. Okay, anyway, look, so the point, so no omit frame pointer looks like this. We do.
Way worse, holy shit.
Right, so okay, maybe we can have compiler sympathy where this is the thing they wanted to get rid of, which is you have to do push RBP, move RSP into RBP.
Well, it's also like all that push RBX.
This is for the malloc, I think.
Oh, right.
Or is it?
Well, I mean, try it without FNO event frame pointer.
Wait, no, it's these guys.
Okay.
So
Yeah, that's not that bad.
what it's doing here is it's saving num1 and num2 onto the stack
Right.
to do the call. And you could say like, hey, why doesn't it move it to call these saved? Well, because then it would have to spill the call these saved to restore it.
Which is the same as what it's doing.
Yeah. So.
But it still seems like the smarter thing would just be like doing like subtract the stack pointer by 16 and then just move it.
No, I'm pretty sure push is like, because push is old, push is like small. No, but it's small. So pretty sure, is there a way to show, where do we show the hex here? Link to binary. Here we go. You see the push is a 1 byte. Which is actually, that's pretty crazy.
Well, there's this cool thing in the x64 encoding where like these instructions, the really old ones,
Yeah.
like let's suppose, the push opcode is 50,
Mm.
right? And like for push a different register, you just add the register value to the opcode.
Oh, right.
So you do like literally, push plus RCX, and that's the real opcode.
Well, in this case, we have push RBX is 53, and push RAX is 50.
Yeah.
Push RBP is 55. Push and pop. So I guess this makes sense that like push and pop are like small. So maybe we should be using push and pop. I don't know.
It's weird that push racks is longer.
Then no, you were looking in the wrong place.
Oh yeah.
This is for move.
Right. So yeah, it's push 50 is the real opcode, and then like RBX is 3. So you add 50 plus 3 equals the push RBX opcode.
Yeah.
Which is kind of neat.
Yeah. Okay. So this was. So the no emit frame pointer stuff is okay. We're doing these saves. Then we're doing. Wait, what's this? RBX RDI. Where does RDI come from?
Well, it's a parameter.
Yeah, but I'm doing malloc 7. Wait, like, what is happening?
RDI is part of the ABI.
For what?
For the system 5 stuff.
Yeah, where do I...
Maybe
Where's the description of the
maybe
system 5?
ChatGPT. It was ChatGPT. How do you get Kagi's in default, by the way? I'm trying to do that, and it's like...
Kagi
it's
to
like,
what?
You can't change your...
Yeah, it's kind of annoying. I know, the Brave people kind of messed up. They really want you to use their own...
Yeah, which sucks.
Yeah. Oh, let me ask ChatGPT 5 as my semantic search. Wait, I wish we had debug info in Godbolt. That'd be cool to be like, which value is this currently containing? Maybe, I don't know.
You can like click on something and it'll show you in the left panel.
Yeah, but it doesn't the lines, I think.
Yeah.
Here we go.
Right, because Clang doesn't have, as we know from Whitebox and Spencer modeling, Clang does not have actual character level info. Even though it has the API for it, it doesn't actually implement it.
Wow.
It has like get start column.
Oh yeah,
Get end column, but get end column just returns
Yeah.
start column.
Andrew was commenting on that when we were debugging the other day. He was like, "Oh, look, there's some nice column-based debug info going on here." Because the Rust compiler does emit column debug. Label the assembly with comments that indicate what value is in what register. It might be that we have to. Oh, I think I know what's going on. Okay, so I think it's pushing RBX in order to use it. That make sense? Yeah, so in this case it does, oh look, I need to go to the washing. Why don't you take my place here? And then you can like draw a calling convention. So we'll
I don't know what a calling convention to draw, bro.
just draw the rest of the calling convention.
Just draw the rest of the album. There's not even. Draw the whole album.
You have to sit here and talk like in this direction. You see? Your face has to be like here. This is your face.
Bro, I need to figure out the laundry thing. Desperately.
Yeah, but I'm doing it now. So look, you gotta entertain the people. While I.
No. My very slowly typing.
Bro. Like, you know you can just fix it.
No. Ah.
Alright, well, I can sit here now.
Yeah.
How much what did you...
I accomplished half of that sentence in that time. I'm like scanning your keyboard for keys.
Wow.
Of course, it takes the maximally
Yeah. Yeah, bro. I think it might be over. But okay, this is no emit frame pointer. Wait, this is legal.
Okay.
Right? Like this is it's allowed to do this with the emit frame pointer.
Yeah.
So I guess the thing it's enforcing, you have to enforce 16 byte stack frames to keep the alignment, because like there's a bunch of SIMD code that will run inside like libc that will freak out if the stack is not 16 bytes aligned. Yeah.
I mean, you don't care about it.
I do, because we have to call libc through shims. You can make shims.
Yeah, the shims could do the stack alignment.
Yes, but actually you want to be like, I don't know. Because we have to, on RISC-V, we have to be 16 byte aligned always. And that's because, so because of this 16 byte thing, there are compressed instructions for decrementing the stack pointer on RISC-V in multiples of 16 bytes.
Okay.
So you want to be able to use that actually. Anyway, dude, what even are the registers?
You don't know the registers, bro?
I know,
It's over.
I know, but I forget like what the registers on CC format are. RAX, RBX, RCX, RDX, SI, DI, BP, SP, R8, R9, R10, R11, R12, R13, R14, R15. Okay.
It's probably worth considering, like, alright, what are the ones that I can't use? And then just work backwards. Because you can use all the other ones.
So on system 5, floating point XMM call Lee saved. Wait, call Lee saved. RBX. Why is RBX call Lee saved? It's there.
Yeah.
That's super wacky. You can't use RBX.
Like, you're just wrong.
Yeah, I mean, yeah, the Wojaks are funny. Especially this Wikipedia Wojak. It's super funny.
The Wikipedia one is so good.
I kind of think this is dumb and I want to do something different. That's my feeling right now. Look, maybe we should actually try register allocate for x64. Maybe that would be good.
What? Register for x64? Yeah. I would think so.
How, wait, but okay. But there are many registers you like can't use because they have dumb implications. Like you have to do a CBQE or whatever the thing is. So RAX, RDX is wacky. Okay, here's the idea. You could do a register allocation where everything is spilled between blocks. Like on block boundaries, but within a block, values can stay in registers. So you're just tracking some state of like these value numbers are currently in these registers. And then, because that's pretty easy to do. And then you get to the end of the block and you like just have to flush those.
I wish I could be more helpful with my brain.
Why is your brain?
It's white noise, I don't know.
Your brain is white noise.
I think Yocto told me.
Yocto.
I can't say what it is.
Okay. Well, is it super funny? Okay, hold on. I'll mute. I'll mute. Okay, funny thing over. So look, you can't use RAX or RDX because of mol and IDIV. You can't use CL because of shifts. String and memory instructions? Alright, whatever. Okay, hold on. So we can't use... Which are the registers that we could use? We could use... The Corley saved registers are RBX, RBP, R12, R15. Then not that many. We could also do the flush on function call. Bro, there are like no registers on this thing.
Welcome to X64, dude.
No registers.
There's 16, it's fine. I know you're used to infinite registers.
Okay, so like here's my plan. You can't use REX and RCX and RDX because those have funky behavior with some instructions.
I mean, well, you can, and most calling conventions do.
Yes, but I'm not even talking about the calling convention now. I'm talking about the register allocation
Eat those,
stuff.
and then, like, you have to eat RSP, obviously.
Yeah.
I mean, you
RBP
can use RBP, but that's a little sketchy.
Is it? Why is it sketchy?
I don't know. I mean, it just means you have to have different rules if you do want to, like, in debug, emit frame pointers.
Well, no, but don't we use the dwarf info for that?
I don't really know how it works. I only implemented it, bro.
He only implemented it. What? Look, you did here. Def CFA offset 16.
It's telling the dwarf info that you're pushing the frame pointer and stuff.
Oh, bro. What did you do?
I don't know.
Anyway, I guess we're gonna keep pushing RBP. So we're not gonna emit frame pointer.
You can always change that. It's not that.
Okay, so we can't use RBP, RSP.
You can use RSI, RDI, and then all of these.
Yes, but some of them are call-e saved and some of them are not call-e saved.
Well, you get to decide that. So.
Yeah, I guess so. But this is not even the calling convention. This was like, how do you register allocate while not, whatever.
I mean, but that is, I don't know, it's highly related.
I guess. But wait. Do we have to be able to be called by a sysv thing?
Why would you?
No, probably not.
You'd only really care about that if you're doing a callback.
Yeah, so I guess wait, why is RBX not used for anything? There's some historical.
I mean, you could just ask PPT that stuff.
Okay, what we're gonna do is we're gonna have is it? It's we're gonna register allocate across RBX. And then RBP, so we don't want to omit frame pointer.
It's probably easier not to for the time being.
Hold on, wait, I have a crazy.
RBP would be like very helpful.
I have a crazy idea. Some debug info commands. What are they? And
I want to try to correct your commas.
so this code would not compile. Call frame address. Wait, call a stack pointer reference point. We use RBP as the frame pointer. The caller's frame is at RBP plus 16.
Think of all of the activities happening on your non-streaming monitor.
Yeah. I mean, I don't know, I feel like
Collapse your sidebar.
yeah, so you can't like show this.
Hey, you can collapse the sidebar. Boom. Share.
I guess so.
So many people know what kind of shit you chat GPT.
Exactly, you know. Yeah. Instead, describe the frame purely in terms of RSP and stack adjustments you make. So on entry, RSP points to return address, CFA is RSP plus 8. Every push lowers RSP by 8, so increase CFA offset by 8. Oh my. Okay. Push RBX. Adjust CFA offset. Wait, why do it? What? Unwind the debugger. Oh, okay. Okay, so here's where we're at. Here's where we are at. I think I'm just gonna try to do like a smaller version of the RISC-V thing, which is we're gonna do all callee saved. Minus, I guess, the registers that the procedure uses as arguments. So that means RBX, RSI, RDI, RBP.
I don't even remember, like, what is the advantage of doing call message? I don't remember this.
I'm not sure either.
Yeah.
John was tweeting about it, and I don't think there's an answer yet.
Yeah, wasn't he asking, like, why don't we just do all call message? Or call usage?
No, he was asking why don't we all do caller saved? I'm pretty sure the answer is all call leave saved, but yeah, it's whatever. Anyway, the point is we have all of these that we're gonna use. But they... Wait, what does this mean? We've actually managed to get 12 registers, I think. Pretty good.
Wait, which ones? So you get all of the numbered ones.
Yep.
You get RDI and RSI, that's 10.
RBP and RBX.
RBX.
Yep.
Okay. Right, it doesn't have any weird side effect things, right?
Yep.
It's all RC or RDX that do that.
Yes.
Reasonable.
So we can then. So what's our preamble going to be? The preamble is going to be we enter. We can use one of the volatiles to subtract from RSP.
Volatiles.
Yeah, like one of the non-saved registers. For example, we can do in here, do blah 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 blah. See, we're not going to do push RBP anymore. We're just going to move the stack pointer down like this.
Well, why would you use a register to subtract RSP? You just put the size of the stack. Okay.
Maybe?
That's what you do. You just put like the immediate.
I mean, wait, we'll have to fact check that with
Yeah,
Godbolt.
I mean, you do like sub RSP 16 or
Android
sub
Kotlin.
RSP
So,
40.
wait, what?
You just do like sub RSP 40 or whatever it is, and then you do add RSP 40.
Yeah, but you want to be able to support like huge amounts.
Yeah, I mean, immediate support maintenance. It's fine.
Really? "32-bit mode. This does not work, but doing oh, really? GNU as. Yeah, operand size mismatch. So what you can do is you can do. Wait, what's the official way to create a constant? Like instantiate the literal in x86 assembly. What?
What you could do though is like you can just do this conditionally, where you do like if it fits in the immediate, then
Yeah, but I don't want to do that for this code. Wait, what is it I do current? The current thing that is working is this. Wait, what? Oh, so I'm just doing the sub thing.
yeah.
So wait, why does it? Where is it complaining? You use sub 8, right? No. What?
It may want you to do some gay like D word thing. Or Q word.
Operand size mismatch for sub. Oh, wait. I think I'm not in .intel syntax. Come on, bro. Come on. We're waiting. What is up with that? they like under load in this moment? We can just try this. We're gonna presume for the moment that this works. So we'll do sub RSP some amount. That's what does 100% quality saved mean? That means we need to save these registers to begin with. Right? That's what it means.
Yeah, you save them.
Yeah. So.
But you only need to save them if they're used.
Yeah, but we're gonna assume that they're used in this simplification.
Right. Always spillers.
Yeah.
Isn't that gonna be slow as fuck though?
Yeah.
It kind of defeats the purpose a little bit.
Well, look. Right now we spill on every ad. We run like.
Oh no.
Have you seen the output?
Yeah. I mean, I can't really make sense of it because it's not like structured in any way.
Okay, so. Eight Corley saved registers that we need to save. We then have which when you do minus 16. Yeah. Oh, that's me. I have to go look at the thing again. Combining streaming with the day you have to do the washing maybe isn't a super fantastic idea. Wait, how do you even pass stuff on the stack if the next guy is going to also be pushing things?
What do you mean? You know the offsets.
No, there's like a name for some kind of structure. Can't remember what it is, but it's like. Yeah, it's like on the other side of the base point. Like there's something like this where it's like it goes above somehow. Yeah, look, we got like parameters, then the return address, then the local variables. Anyway, I'll be back in a bit. 2 to 3 minutes. what I'm thinking. How do you pass something on the stack?
You put it on the stack.
Before or after?
Before.
What happens to your stack frame? How does the stack unwind still happen?
You just know the offsets.
Be
I know
specific.
I don't know these things, man. I forget these things when I stop doing them.
Like, bro, you gotta be helping out using your brain. RSP plus. The red zone. See, this is what I'm saying. There's something called the red zone. Do you know if are people watching this stream?
There's like 5 people last time. It's currently none.
Nice.
Just me.
How do you stream and have viewership?
You get in pointless arguments on X.com.
Really?
And then you tweet. Like once you have like 20,000 followers, you tweet. And you go, I'm streaming live right now.
Yeah, well, I'm thinking like Handmade Hero used to be like, that's like good content, kind of, but it's a stream.
Yeah.
I guess you kind of have to be like
Yes,
driving.
no.
Well, yeah, but even like at the time, I don't know. It's the kind of thing of like you're sort of live performing good content. I guess.
Content, bro. Content trademark. That's the key.
you want to eat lunch and talk about calling convention?
Maybe like take a shower, not Randy style. Listen to the white noise for a little bit. Then eat food.
Alright, well I'll join you for the food. Maybe I can ship something for the stream.
Yeah, please don't join prior to the food.
Okay, so there's no more washing to be done now. So we could get some actual productivity going. However, I'm gonna make coffee first. Okay, we are back because the coffee is brewing. So I need to learn about this red zone thingy. As the red zone, okay, so I think it's gonna look like this, essentially. We have RSP points to here. And then above it, well, I think I'm gonna do this. So okay, we do the call that pushes the return address onto the stack. Okay, so we get this, right? Then we move down and we have a stack arg. Then we push some then we push call e saved. We do some of those, and then we can start going. Wait, hold on. And then we need to copy. Or do we? Everything is an 8-byte value. Oh, and what do we then do with stack space? So we've got this proc argret reg count. We've got the same thing for stack count. And then we have a space reservation after that. Which in our case is the value numbers plus other stuff. So we need to save this position here as stack arc offset. And then we can say a certain range of value numbers is in here. Then we've got and even there we have a distinction between global and local. Okay, let me get this coffee. Does this make sense? I think it does. Looks like this now, Mr. Brendan.
I see.
Who else? Space Reserve. Wait, no, it's this guy plus this guy. This guy, and then we're gonna add and there we go, that's our full offset thingy. Put this here. And then RSP offset, stack arg offset. We will also declare this, it's visible. We do the fix up for him. 1790. Ah, yes. Undo that. Do this. Well, actually, all of this needs to be redone. Now I just want to do that and then go look at a procedure in the file. Okay, so I'm gonna go eat food and then we will continue with this afterwards. But I'm gonna pause the stream. Until, well, yeah, we'll do another stream after I've eaten. But the plan is basically, okay, we're gonna use this and then we have to redo the basic block emission structure to have this kind of ad hoc register allocation thing that just does something, which is going to be a lot better than what we currently do. Probably there'll be massive speedups on Linux from this. And then, because it's sort of comparable, once we have some kind of basic-ish register allocation on x86, I want to, like, we have you know, I have stuff here where it's like we do some SIMD stuff that I got from other compiler outputs that we've just chucked in here. And I would like to, it'd be cool if we did not need to do these. Especially because we want to be a little bit more I was going to say we want to be more compiler or SoC agnostic, and we're going to be dropping v0.7. And so, yeah, you know. It'd be nice if I could profile in Valgrind without having the numbers be very inflated and diverged from reality on the platform that we care about.